Hello students, myself Dr. Sofia Gupta. So today we will learn how to calculate the effective nuclear charge. So basically the effective nuclear charge, it is the net charge which is experienced by the valence electron in an atom. The formula to calculate Z effective is Z minus sigma, where Z is the actual nuclear charge, or you can say actual atomic number, and sigma is a screening constant. For example, if we want to calculate the Z effective for 2p electron of sodium, then Z effective will be Z minus sigma. What is the atomic number of sodium? It is 11 minus sigma. So the main task now is to calculate the value of sigma. Sigma is screening constant. The value of this will be calculated with the help of Slater's rule. Now we will start our Slater rule. This is very simple rule. Just first you have to do the grouping according to the value of n. So what is n? N is principal quantum number. For example, like previously we have discussed about sodium. Firstly you have to write the electronic configuration of sodium. Now sodium having the atomic number 11, the electronic configuration is 1s2, 2s2, 2p6 and 3s1. Now according to the rule we have to do grouping according to the value of n. So n is this one, 1, 2, 3. Now keep one value of n in one bracket and others in other brackets. See, like this you have to do the grouping. Okay, so first step, always you have to do the grouping according to the value of n. Now if you are asked about like iron, you have to calculate the Z effective for the iron. So we know that the atomic number of iron is 26. Write down the electronic configuration: 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d6. Now here basically this is an important concept, that here you have to do the grouping according to the value of n. So what you have to write, see, 1s2 this one, then 2s2, 2p6 in other group, then 3s2, 3p6 in another group. See, now 3, 3, 3, you have to take this one in this group. This is the main thing that you have to consider. Okay, so see, 3d6 you have to consider in this one group, then is 4s2. So this is the main step of doing the grouping, both in S and P groups and D group. I have told you how to do the grouping according to the value of n. Just you have to consider the value of n. Now the rule number 2 is this one table. This I'll explain you. See, now see, the second rule. Okay, second rule is, now you have to learn this table. This table is very important. Now if your question is to calculate for S and P electron Z effective, then what you have to do, the contribution of nth shell will be 0.35. For n minus 1 shell it will be 0.85, and for the remaining shells this is 1. Okay, this you will get clear from an example. Let's take a same example of sodium. Now the question will come, calculate the Z effective for 2p electron in sodium. Okay, we'll start by step. Firstly you have to write the electronic configuration of sodium. Sodium is 1s2, 2s2, 2p6, 3s1. Clear? Then the second step is you have to do the electronic configuration. You have to pair up according to the value of n. See, this one pair, then this one, then this one. I hope that is clear. Then what you have to then see which electron they are asking to calculate the Z effective. It is 2p electron. Okay, so this is a 2p electron. Now you just mark 2p electron. For one electron we have to calculate. So what is the value of n over here? It is 2. Okay, so this n is now 2 for sodium. We have to calculate for p electron. So basically Z effective is Z minus sigma. Z is 11 and sigma. Now we have to calculate the sigma. So for one electron we have to calculate. So just exclude this one electron. Now the remaining electrons are 5. Okay, 5 this. In one bracket total how much electron? 2 of S, and total there are 7 electrons. So 7 into how much contribution? N is 2. How much contribution? 0.35 plus for n minus 1. So 2 minus 1 is 1. For this how much electrons? 2. 2 into how much contribution? 0.85. Okay, from here you will get the value of sigma. Now you will have the question, why we are not considering this electron? For all those electrons which are coming to the right of the bracket, their contribution is 0, like whatsoever, like you have to calculate for this. So the electrons which are to the right of this, their contribution is 0. So this will be the sigma for the sodium. Okay, now you can easily calculate the value of sigma. Now you can sidewise you can calculate what is the value of sigma. 7 into 0.35, it is 2.45 plus 2 into 0.85, the value is 1.7. When we do the plus of these two, we get 4.14. So what is Z effective? It is Z minus sigma. Z is the atomic number. So you simply have to subtract 11 from 4.15. So the answer will be 6.85. So the Z effective for 2p electron of sodium is 6.85. I hope you got this. Now for D and F electrons, the rule is slightly different in the sense that here you have to consider 0.35 contribution of the n electrons, and for the remaining you have to consider 1 the contribution. This we will clear it from an example. Now for example, your question is calculate the Z effective for 3D electron in V. Okay, so what is V? It is vanadium, symbol for vanadium. Its atomic number is 23. So firstly you have to know the electronic configuration. It is 1s2, 2s2, 2p6, 3s2, 3p6 and 4s2, 3d3. The second step main is grouping. So how you will do the grouping? 1s2 in one group, then 2s2, 2p6 in other, then 3s2, 3p6, 3d3, then 4s2. This is very important, the grouping. Now they have asked for 3d electron. Okay, so in this basically, firstly for calculating the Z effective, we are having Z minus sigma. Z is 23 minus sigma. Now to calculate the sigma, the rule is you have to calculate for 3d electron how much electron for one electron, they are telling 3d electron, how much left? 2. It's they will contribute 0.35, and the rest, the remaining will contribute 1. So it is 6 plus 2 8, 8 plus 8 16, plus 2 18, 18 will contribute 1. So this is the rule for the electron which are in 3D. Now we can do its numerical portion. Students, you can do side by side on your notebooks. So calculate 2 into 0.35. It is, I hope you are doing that in your notebooks. 0.7 plus 18. So what is it? 18.7. So Z effective will be 23 minus 18.7. It is 4.3. ठीक है, it's very simple. Now see, if the question comes you for example to calculate it for 4s electrons, है ना, it can be like calculate the Z effective for 4s electron in vanadium. Now same grouping you have to do, है ना, same, this is like 4s grouping, you have to do it same like this one 4s. So here n will be 4. How much basically Z effective is Z minus sigma. Z is same 23 minus sigma. The steps to calculate sigma is 4s. Now how much left? 1 into 0.35. Okay, then n minus 1 is 3. Matlab you have to consider this full bracket. How much total electron? 6 plus 3 9 plus 2 11. 11 will contribute 0.85. Okay, plus then rest all apart from n minus 1, rest all will contribute 1. 6 7 8 9 10. 10 electrons will contribute 1. So you can calculate the sigma. Same 0.35 plus 11 into 0.85. This is 9.35 plus 10. Do its addition. 0.35. It's 19.7. So Z effective will be 23 minus 19.7. It is 3.3. I hope students the basic concept how to calculate Z effective is clear. Now there is one exception in that, like the exception is 1s electron. The exception is that 1s electrons, they always contribute 0.30. This exception you have to remember. Okay, so we'll do a full-fledged question in which the whole of the Slater rule will be covered. So yeah, let's start. Now the question is, let's take a simple question. For example, let's take you can take titanium. The question will be to calculate Z effective for 3d electron in titanium, 2s 2p electron or 1s electron in titanium. Let's do this 3 questions and whole of the rule will be very clear to you. Firstly, what you have to do is to write the electronic configuration of titanium. What is the atomic number? Yeah, it is 22. So 1s2 2s2 2p6 3s2 3p6 4s2 3d2. Okay, now what you have to do is, now the second step I've told you to do the pairing. Now pairing according to n. So 1s2 2s2 2p6 3s2 3p6 and 3d2 then is 4s2. This is a very important step of pairing. Now the first is you have to calculate for 3D electron. I'll tell you how to calculate sigma. Firstly we will calculate the sigma, then we will subtract it from z, that is atomic number, will get the z effective. Okay, so for what we'll doing 3D. Okay, you have to mark 3D is this one. Okay, for D, what I have told you, just consider the D electron. For 1 we have to calculate how much remaining 1 into 0.35. For all to the this one left, the contribution is 1, because from the bracket if we are going to the right, the contribution is 0. Okay, now calculate how much electron. 6 plus 2 8, 8 plus 6 14, plus 2 16, plus 2 18, 18 into 1. This will be the sigma for 3D electron. Now see, this is 18.35, so Z effective will be 22 minus 18.35. Calculate on your copies. It's 3.65. Okay. Now the second question was to calculate for 2s and 2p electron of titanium. Okay. Okay ji. Now we have to calculate either for 2s or 2p, because the answer will be same. If the question comes now for 2s electron, we will get a particular answer that will be same for 2p also. Okay, for 2s electron or 2p electron, whatever, see we will consider, we have to calculate for 1 electron. Okay, to the right of it the contribution is 0. Okay, now you have to consider for the left. For 1 we have to calculate, so exclude that one. 5 plus 2, 7 into 0.35. Now here n is 2, so for n the contribution is 0.35. For n minus 1 the contribution was 0.85. n minus 1 matlab here 2, 2 minus 1 1. For this 2 electron the contribution is this one. So students, you can calculate how much it is coming. So 7 into 0.35, the value is 2.45, and for 2 into 0.85 the value is 1.7. You can add these values, it is 4.15. so Z effective will be 22 minus 4.15, 22, it is 17.85. I hope that is clear. Now the last is for 1s electron. Let me choose a different color. Yeah, third is for 1s electron. I've told you for 1s electron it is having an exception, its contribution is always 0.30. See, we have to calculate for 1s electron, then the right of the bracket the contribution is 0, matlab all the electrons they are contributing 0. We have to calculate for 1s electron. For 1 electron we have to calculate, so exclude 1 electron. How much remaining? 1 into 0.30. So Z effective is 0.30. No, this is the value of sigma. Sigma is 0.30. The value of Z effective will be 22 minus this much. So what will be the answer? 21.70. I hope students you are now getting an idea how to calculate Z effective. By following this rule you can calculate the Z effective of any like electron you are given to calculate Z effective. So thank you. In next video we'll come with a different topic. If you are having any queries you can comment below. I'll try to answer each one of your queries, and yeah, you can also suggest me which topic should I teach that you're like feeling it is difficult, or it is like it is very elaborated. I'll teach you in a very briefly manner, exam point of view manner. So yeah students, I hope the topic how to calculate the effective nuclear charge is clear. You can pin down your queries. Thank you very much.